In this lecture, we will discuss about acyl substitution. Acyl substitution is mainly given by acid derivatives. A general reaction can be shown something like this. Let us discuss the mechanism for this reaction. Mechanism involves two steps. First step is nucleophilic attack, and this is addition step. So this is nucleophilic addition. Initially this carbon is sp2 hybridized, and finally this is sp3 hybridized. Now this intermediate is also called a tetrahedral intermediate. Second step is loss of a leaving group. So we have a tetrahedral intermediate, and this loses a leaving group, and carbon oxygen double bond is again formed. So this step is elimination step because loss of a leaving group. This carbon is sp3 hybridized, and finally this becomes sp2 hybridized. So if you see, the whole mechanism is basically addition elimination mechanism. So first step is addition and the second step is elimination. So we can say overall reaction is nucleophilic addition elimination. So acyl substitution is also called as nucleophilic addition elimination. If you see the hybridization, initially this is sp2, it changes to sp3 and finally it becomes sp2. Let us consider some examples of nucleophilic addition elimination. One example we have, that is hydrolysis of acid chloride. So in this case H2O is nucleophile. So we will have a tetrahedral intermediate. In the last step, water can lose H plus. Finally, it will be converted into acid. So this is hydrolysis of acid chloride. Similarly, we can have hydrolysis of ester. It will follow the same mechanism. So we have to break from here and we have to add OH, and this side we will have ROH. So acid plus alcohol. Hydrolysis of anhydride will also follow the same path, that is addition elimination mechanism, and in this case we will have 2 mole of acid. Similarly, we can have amide. And this will give an acid base will react. So we will have RCOO minus NH4 plus. So you see, in all cases we have a leaving group. So for acyl substitution, acylic carbon must have a good leaving group. So in this case, chlorine is a good leaving group. In this case, alcohol is leaving group. In this case, acid is leaving group. In this case, ammonia is leaving group. Aldehyde and ketone does not give acyl substitution. So let us say if I have aldehyde, first step is addition step that takes place, but the second step, that elimination step, that cannot proceed, because in this case H minus is not a good leaving group. Same is the case for ketone. We can have first addition step, it will form tetrahedral intermediate, but the second step, because in this case R minus cannot act as a good leaving group. So here also this step will not take place. At one place we have this kind of reaction where we can lose R as a leaving group. That is haloform reaction, if you remember. If you remember haloform reaction, we can lose basically a leaving group in this case. So we are writing a short mechanism I2 and NaOH react with this molecule to form Ci3. In the next step, OH minus adds on carbon to give nucleophilic addition. So this is addition step. Now in the next step, generally we said we cannot remove this as a leaving group, but this is the exception because Ci3 becomes a good leaving group because of 3 minus I groups. So this is a good leaving group. So in this case, we will lose Ci3. And the final is Ci3 minus can take proton from here to form CHI3. So in a special case, in a case of halopalm reaction, we have very similar to acyl substitution reaction. Otherwise we have acyl substitution only on acid derivative that has a good leaving group attached to the acyl carbon. So in this lecture we discuss about addition elimination mechanism. First step is nucleophilic addition. Second step is elimination. So overall this is a substitution reaction.